Um, Welcome again to all of you. Thank you for joining us today for this introduction to life cycle assessment and how it relates to the MSI. My name is Stuart Shepherd. I'm the Director of Sustainability and Training at Higg, and I'm joined tonight by my colleague Paula Bernstein, who is our data manager for all the Higg tools, and Paula will be leading the presentation today. Just a few technical or admin details before we start. Please enter your questions in the Q&A box at the bottom of the screen, not in the chat. The Q&A box enables us to track them, to make sure that we have answered them. We can also answer them by text rather than taking them live if they are different or don't need to be taken live. So please use the Q&A box. And secondly, this session is being recorded, so if you have an issue with that, please let us know immediately. And this recording will, of course, be made available to all of you in the follow-up email that will come after this. But for now, it is up to Paula. The floor is yours. Thank you, Paula.
All right. Hi, everyone. Thanks for joining. And thanks to Stuart for inviting me to present to you guys on this session. So like he mentioned, I'm Paula. I'm a data manager at Higg, and I'm responsible for all the data that goes into MSI and product module, that the data that measures environmental impacts. I've been at Higg for a little over 2 years, and before that, I worked at an LCA consulting firm and an LCA software provider. So my background is working on all kinds of LCA projects, as well as LCA software and database development. So let's get started. For our agenda today, we're going to do an introduction to life cycle assessment. So that'll include how the MSI leverages LCA data to assess environmental impacts of materials. I'm not really going to get into the mechanics of the MSI or give demos inside the tool. You can see that in a separate MSI onboarding webinar that's, I believe, on the How to Higg website. So there's recordings, and then we do them every so often as well. Today, instead, I'm really just going to focus on LCA methodology and the approach and relate that back to the MSI. So we're going to start, we're doing the introduction now. Then we're going to get into our LCA 101 overview for majority of the time. And then we're going to finish with, we'll pause for some questions after I get through that section. And then we'll move on to some hot topics in LCA, and therefore some hot topics also in MSI. This is just the tip of the iceberg and a high level overview of these concepts. Some intro to LCA classes can be full day, like 8-hour classes. So keep that in mind. We're just kind of scratching the surface of this methodology. There's a lot to go through. So feel free to put your questions in the Q&A box, and we can get to them in the middle of the presentation, and then we'll have some time again, probably at the end as well. If we don't have time, we'll also follow up. If you are interested and want to go deeper in taking some courses, I can send you some resources that I know of, some consulting firms that have pretty in-depth LCA classes. So feel free to put something in the Q&A box, and we can follow up with you as well on that. So let's get into our overview. So LCA is a scientific method used to analyze environmental impacts of a product throughout its life cycle. This is a pretty classic visual representation of LCA with the life cycle stages of a product. The arrows here representing inputs from nature to the process, and then all of the outputs, so emissions, wastewater, and waste emissions to the earth. You might have heard the terms cradle to gate and cradle to grave. Cradle to gate includes raw material and raw material processing, while cradle to grave includes the full life cycle from distribution, use, and end of life as well. So MSI and product module through the finished goods manufacturing are cradle to gate, and because they both measure impacts through the processing stage, while the full product module is a cradle to grave tool. So LCA allows you to identify hotspots or understand what phases contribute most significantly to environmental impacts. This is just a made up product showing impacts from cradle to grave. You can see the different stages down here. You could just as well have the same chart with MSI data, and you'd have raw materials, yarn formation, textile formation, and the different textile processes down here. And really, this is important because we can understand what phases are the most impactful for environmental impacts, and then allow you to focus your efforts on what's most important. So if in this example, if this is our product and we're most concerned with global warming, then maybe we want to focus on raw materials since they contribute 50% of the impact. But maybe we're really concerned about water scarcity, and so we can look at the use phase because that's a majority of our impact. So it really helps you identify what are the hotspots at all the different production phases. LCA is also a great tool because we look at multiple impact categories, not just one. One material might be better in global warming, but might have higher water use and higher eutrophication impacts. We see that a lot in bio-based products, which is not surprising since they use something grown from a plant on a farm that would probably use more water than fossil fuel-based materials, which typically use very little water. So basically, by looking at multiple impact categories, it avoids burden shifting, or, if maybe saying that you have lower global warming, but that might increase your impacts everywhere else. So it forces you to look at have a more holistic look at your product. So I'm not going to talk about this too much, but I want to mention that there are several international standards for conducting LCAs. So we're not just, this isn't something that we made up. We follow guidelines and follow these different standards that are out there. The most famous is the ISO standards listed here, the 1440 and 1444. The European product footprint is a project going on in Europe that I'll mention a bit more later, but that has some really great guidance. And then the Greenhouse Gas Protocol has accounting standards for greenhouse gas reporting. And then we also have the European Standard for Construction Products, which might not seem super relevant to us in the apparel industry and hard goods industry, but it really has some good general LCA guidance where some of the other standards are lacking. So we use all of these to inform the methodology in the MSI. So traditional LCA workflow, LCA practitioners and consultants conduct LCAs for companies on their products. And often at the end of the project, they deliver a report that outlines the study and the analysis of the environmental impacts of that process or product. To do so, they use a pretty complex and also expensive LCA software, and that contains an LCA database. So, and then at the end of that analysis, you get a static report, usually in like a Word document or PDF document. So I think MSI kind of fits between the LCA software and LCA report, since it's kind of a simplified LCA tool. We don't, of course, produce a report, but we make interpretation a lot easier and streamlined, and allow users to have access and understand the LCA data without necessarily having to learn how to use the LCA software or to hire a consultant. So there are 5 steps to an LCA study as defined by ISO. Almost all the LCAs that I've ever seen follow these 5 sections as like their top level headers. I'm going to dig into each of these in more detail in the following slides, but at a high level, you start with defining the goal and scope of the study, followed by life cycle inventory or modeling, then the life cycle inventory analysis or results stage, followed by an optional normalization and weighting step, and finally your interpretation of the results. So to start out, the goal and scope phase is step one, and that's exactly what it sounds like. So you're identifying the goal of the study and the exact scope of your study. The first really important concept here is called the functional unit, which is basically the most fundamental part of an LCA. The question is, what is the comparative basis or the service delivered by that product? In MSI, we use 1 kilogram of material for all of our, for everything in the system. This is pretty common in a cradle to gate LCA since we don't know what the final product is going to be. So will the polyester be used in a t-shirt or a shoe or a toy? We can't really measure the function of it if we don't know what the final product is. So we use 1 kilogram for all materials as the measurement basis. The system boundaries are also really important. This helps us answer what should we include and what should we exclude. As I mentioned before, MSI is cradle to gate, so we do not include use and end of life stages. We also include what's called the cutoff at recycling model, and that's something I'm going to dig into in the next slide. But basically, it's really important to define the system boundaries so everything in the tool and in the database is consistent. So I have more details on both of these points on our next 2 slides. So here is a really good example of how important a functional unit is. A good example of looking at this is with insulation products. I know there are some studies out there that have looked at LCAs of different insulation products, and they picked a functional unit that took into account what's called a CLO value, or basically the warming power of the material. So just a caveat that the data on this slide is an illustrative example, and this doesn't reflect our actual data or any data. This is just to give you a sense of a functional unit and how it could possibly matter. So basically, on our top example here, on a per kilogram basis, let's say down or feathers have a higher impact compared to like a synthetic polyester insulation. But if we look at the warming power, maybe you need twice as much synthetic material to warm you the same way. So maybe they're the same when you look at the warming power. But if we're talking about how long it lasts, maybe the down lasts 20 years and you need to replace your synthetic coat 4 times to equal the single down coat. So this just is kind of demonstrates that the comparative basis is really important, and it can change your interpretation. Now, this isn't to say what we're doing at MSI is wrong. We're only doing a cradle to gate assessment, and this is still really valuable since we don't know if the down is going into a coat or a pillow, or maybe you have feathers in a pillow, the warming power doesn't really matter, or maybe it's fast fashion and it's not designed to keep around for so many years, so it doesn't matter if it's durable. So really, this depends on the unique situation of the product that you're looking at. I will say that most LCAs I've seen on materials are cradle to gate and on a per kilogram basis. So this is just something to keep in mind, that designers need to make sure the materials fit the need of the product, just like they do cost or any other requirements. It has to fit the requirements of the actual product. In product module, we do have a durability and duration of service section that starts to tackle this. I'm not going to get into that now because I think that could take up a huge portion of our presentation, but I'm sure that will be covered in the product module training. So if you're interested, I would look out for those. Next, the cutoff at recycling was the point I mentioned also in the system boundaries section. Basically, this is how we measure the impact of recycled materials. There are different approaches to this in the LCA community, but in my opinion, this is the most common approach and also the easiest to understand. Basically, this is saying that for a recycled product, so say we have a recycled polyester made from water bottles that's going to go into a shoe. So this is saying that 100% of the impacts of the original extraction and production of the virgin polyester belong with the water bottles. And then any transportation and processing that's required to turn those bottles into the shoe, that belongs with the new product. So it's a pretty clear, it's called cutoff because you have a pretty clear boundary of what belongs with the original product and what belongs with the recycled product. So all materials in MSI followed this rule consistently. Another important piece for us to look at is what stages we have in the MSI tool and how we organize data so that it's all consistent and users can swap processes in and out. What we call the taxonomy is how data is organized. All textiles have these stages here, which are different than the leather stages, different from synthetic leather, plastic, etc. Each category has consistency within its own category. So you can switch different raw materials, you can switch yarn formation in a consistent manner and know that the boundaries are the same. So this provides the most flexibility to the user and also ensures we have consistent boundaries for every process and material. Also worth noting that within each category, different materials have different processes available. So like we've had submissions of dyeing of polyester. So that's only available for polyester and only available in the coloration section. So we customize it as much as we can. So the next step after we define our goal and scope is the lifecycle inventory stage, which involves collecting data and the actual modeling of the process. So we ask the question, what are the material inputs as well as the energy inputs, and then what are the emissions and the waste for every single process at every single stage. So I'm not going to get into a lot of detail about modeling. This is something that we collect data outside of the tool and then create models in our LCA software. I'm not going to get into the details of how this works today, but we may schedule a session down the road if there's interest in that. So now we have our LCA models built in our LCA software. And as a result of that modeling exercise, we get a list of the inventory called lifecycle inventory that we have here on the left. Basically, this is the list of all the resources extracted from the earth and the emissions to air, water, and soil. So this is just an example. I have the et ceteras on here because this is super abbreviated list. This list is often hundreds of lines long and sometimes even thousands of lines long. And so this, again, we get this list with the help of our LCA software. Now, the lifecycle inventory analysis phase involves interpreting the data in terms of environmental impact. So each one of these substances has what's called a characterization factor so that they can be measured in the same terms. So global warming potential is measured in kilograms of carbon dioxide equivalents. So you may have heard that CO2e. You might have heard in the news that methane has 25 times the potency of carbon. So that's something that I've heard people spit around. That's exactly what we're doing here. We're looking at what are the equivalencies of these different substances. After all of these characterization factors are applied to the relevant emissions, we get all of our carbon dioxide equivalents, and then we can sum all of those up to get the total global warming potential for each process. So we sum all these up, and we do that for every impact category. You can see I have global warming here, eutrophication, they all work the same way. There are many impact methods, or LCIA methods, used to calculate environmental impacts. If you're familiar with the MSI, some of these you probably don't recognize from the MSI tool, like ozone depletion or acidification. We do not have those in MSI. Back before I was part of Higg, the Product Advisory Council at the Sustainable Apparel Coalition examined a lot of different methods based on a few different criteria, such as relevance to the apparel industry, completeness, scientific robustness, acceptance in the LCA community, et cetera. And they landed on the impact areas that we have in the MSI today. So this is all documented in the MSI methodology document that's freely available for anyone to access on the How to Higg website. I think they looked at 18 or so impact methods, and they landed on the ones that we are using now. So just know that there are a lot of others out there, and the ones that we selected for a reason. So these are the ones that we have. We have 5 impact areas in MSI. We also have 2 additional metrics that are included in metadata but aren't included in scoring. Only SAC members and paid tool users can see the actual impact results. Basic level accounts can only see the scores, which are derived from these LCIA values. And I'll discuss that a bit more on the next slide. But let's talk about what all of these mean first. We have climate change, which I think most people know. It's carbon footprint, also known as global warming potential. That's one that a lot of people are very interested in. Eutrophication is a measure of nutrient runoff into water causing algae blooms. Abiotic resource depletion is the amount of fossil energy used. So that's total energy, not including renewable energy. Water scarcity is a measure of how much water is used, but also considers the region of the water that's used. So water used in an area where water is abundant is not equal to water used in a water scarce region. So we take that into account. The last scored, or the last primary impact area, is the chemistry method that Sustainable Apparel Coalition developed based on LCA method for toxicity. But basically, instead of just using the toxicity results directly, because they're very highly variable, we just assign a low, medium, or high impact for each process. Noting that this is the first step in a more robust chemistry methodology, and it's fully expected to grow and evolve. This is just kind of the first step. SAC did do a webinar on this topic alone, on just the chemistry impact method. It's also discussed pretty substantially in the MSI methodology document. So those are 2 great resources if you're interested in learning more about the chemistry methodologies. That would be a good place to start. And then the last 2 on the bottom, these are 2 metrics not included in scoring. Biogenic carbon is carbon contained or sequestered in the biomass of a plant during growth. I have another slide on this in the hot topics section, so stay tuned for that. And then water consumption is exactly what it sounds like. It's water consumed during the production process. The water scarcity metric listed here uses this water consumption value, but then it just adds that extra layer of the region. But this is just the water consumed in the process. Some people are interested in that, so we also report that. I should note too that the biogenic carbon content, water consumption, as well as the chemistry methodology were added with the MSI 3.0, which was launched almost a year ago in August of 2020. So those are newer additions to the tool. The next step here is normalization and weighting. I will say that many LCAs stop before this and only include the life cycle inventory assessment results from the previous slide. But basically, normalization is really useful because it helps us conceptualize the score and put them into a common unit. So in our case, we're using points. It helps us answer the question, is 0.004 kilograms of phosphorus equivalent a lot, or is it a little? And I'll get into a little bit more on this in the next slide too, on the methodology here. Weighting, I have grayed out here because we used to do this in the MSI, but we removed this when we removed the single score at the beginning of the year. But I included it here for context because this is something that you can do in LCAs. It's allowed in the standards, and that is why we did it for a while. But basically, this is giving each category a certain weight and then combining them into a single score. This does involve a value judgment on how much importance each category should have. There are methodologies for doing it, and there are weighting sets by researchers that are available. But again, we took this out for a variety of reasons, which I can discuss a little more on our next slide here. So just talking a little bit more about normalization and weighting in MSI specifically. Normalization shows us to what extent an impact category indicator result has a relatively high or relatively low value compared to a reference system. So it just kind of gives us that context of, is this a big value or is this a small value? Is this something I should be concerned about, or is this a small value that I shouldn't care much about? Our reference system in MSI is based on the volume of materials most used in the apparel and footwear industry. So we create this weighted average representative product, which is 32% polyester, 15% cotton, 14% rubber. I think the full list is also in that MSI methodology document. So 1 kilogram of this weighted hypothetical material scores a 10 in all categories. So that's like our framework for moving from the LCIA values that I talked about a couple of slides ago to the MSI scores or the points. There are other normalization systems out there that people use for normalization. Other common ones are like total emissions of the world per person per year. So you could compare your product or material against the world average for that point of reference. Again, yeah, you can read more about this in the MSI methodology document. We've spent a good amount of time on this with the Product Advisory Council, and we revisit this every so often to see if maybe there's some more research or anything else that would be more appropriate. But this remains the best approach for getting those points and those scores. Again, weighting was removed to MSI. Prior to that, all categories were weighted equally and the points were summed up to get the total score. I do have a link here to the press release of why we decided to remove the single score, which I was in complete support of. Basically, instead of looking at that single score, removing it forces users to look at the individual impact categories and sort of weigh those trade-offs that I was describing at the beginning of the presentation. So the last stage in any LCA is the interpretation stage. We can look at the contribution. So how much does each process contribute to the overall impact? Is the raw material driving the impact, or maybe the dyeing does, and that can help us decide where to focus our impacts. This is a screenshot of cotton in MSI. So we can see here that raw material, yarn formation, and coloration are the most impactful areas. In the interpretation, we also do a sensitivity analysis. This involves looking at the assumption of the underlying data. You can play around with the options in MSI to see how choices influence decisions. This is about changing the assumptions, and then this is also something that I do with the modeling. On the modeling side is test how sensitive the model is to other assumptions and different changes. The last thing here is how uncertain is the data. In MSI, we do provide data quality indicators for the user on precision, time representativeness, geographical representativeness, and technological representativeness. Again, this is in the metadata in the MSI, and you can use this how you wish. So it kind of just gives you a sense of, is this data old? You can get, if they're all ones, and that's pretty high quality data. Some of them maybe a little older or might use some more assumptions. So this just gives you an idea of that data quality. So I think we can pause here and take a few questions. If there are any, you can put them in the Q&A box, and happy to answer them before we dig into our next section on hot topics.
So we do have one question from one of the attendees, and that is, why are biogenic carbon content and water consumption not included in the scoring?
That's a really good question. Basically, so biogenic carbon content is just an inventory. So this is getting kind of into the weeds, the details, but all of our impact areas are called life cycle impact assessments, where biogenic carbon content and water consumption are really just inventories, not a measure of the actual impact. It's just saying how much water or how much biogenic carbon. So that's a distinction that we've made. Again, biogenic carbon content isn't necessarily a judgment. It's just saying how much biogenic carbon is in the material. So that's why we just include it as extra information, and it's not included in the score. And Stuart, feel free also to add to that. I hope that that made sense.
Totally, yes.
Okay, great.
There's another question that is, could you tell us again about normalization, what you spoke about on page 19? Each material's environmental impacts are changed into a score with a normalization factor. So
Correct.
and the question is, what does the percentage relate to as well?
Sure. So the percentages are just used here to calculate our sort of industry average material. So we create that material, and then we say that that material would score a 10 in all of our categories. And then everything else, basically normalization is pretty simple math, where you multiply the LCIA value by our normalization factor, and that gives us the points. I hope that's clear.
It is for me, but maybe the person that asked the question can confirm.
Yeah.
We have another question that popped up in the chat that is more general, and that is, we are an assembling factory. We take materials from material factories. Do we still have to take these tests for each material we use, as we only assemble products? No water is needed, only electricity and glue. So how do we take these tests?
Do you want to take that one, or you want me to take that one?
Yeah, I'm happy to take that one. So it's a good question, and there's probably some confusion here. The data that we're looking at, the life cycle assessment data, isn't about a test. It's simply about what was needed to produce this raw material. And so you can look at this and try to, When you make a product, you know how much of glue you use and how much electricity and how much leather and how much rubber or cotton or whatever the materials are. You have a list of ingredients that create your product. You could go on like this where you don't need to have life cycle assessment data, but the interest of a lot of people, brands, organizations now is not only to know what your product is made of, but also what is the environmental impact of making those products. So every time you assemble, let's say, a pair of shoes with some glue, the question isn't uh, that it needs to be tested. The question is how much CO2 or how much gases were released to the atmosphere or how much chemicals were released to the water during the whole creation of this product. So it's not only what happened in your factory where you assembled this product, but also what are the environmental impacts, so to speak, of the materials and of the processes. And the idea of the MSI and the product module is to enable you to do these calculations. So it's not a test. There's no win or lose. It's simply making a polycotton t-shirt with this weight of cotton and this weight of polyester will result in X kilograms of CO2 and the use of X cubic meters of water and X megajoules of energy. So hopefully that answers your question. Then we have another question, which is what kind of data do we need to submit in case we wish to do an LCA or um, join the LCA? So, Brian, this is, I guess it is a two-sided question. Would you like to submit your data to the MSI? So, for instance, if you have a very special product and you know that it is better than standard products, you can create a submission to the MSI so that the data about your product will be available in the MSI. So that's a different data set. And for that, you would simply need to provide us with data around how it's made, how much energy is used, how much water is used, how much material is used, where it's made, what type of factory, what type of processes. Or if you want to do a life cycle assessment of this product and specifically a simplified life cycle assessment of this product, then you would use the MSI and the product module to create a model of this product. You can think of the MSI as a list of ingredients which you put together, and the product module would be um, something where you mix all of these together, and the output, the result of this is these five numbers, these five indicators that say to make your product, you have used or you have emitted X kilograms of CO2, you have used X cubic meters of water, and you have used X megajoules of energy. We have another question, which is around sharing these materials. As I've said at the start, I'll repeat it again for those of you that missed it. You will all receive the recording of this webinar once we send out email afterwards. So every single attendee will receive the a link to the recording and a PDF of the deck. And now there's an interesting question, and that is once the impact and score are identified, does the MSI tool provide recommendations for improvement?
Yeah, so that is a good question. We have different process options in the tool. So if you're looking at cotton, we have recycled cotton, organic cotton. We have a bunch of different types of raw materials, so you can see which ones are performing higher or lower. Same with different dyeing techniques. It doesn't necessarily get into the specifics of your facility or what you're doing specifically to improve, but kind of just more generically how different processes compare to each other. feel free to add to that too, Stuart.
Yeah, thanks. But that was fine. We have another question, which is, would there be a double counting of CO2 if the textile manufacturer report their CO2 and the brand reports it again in their finished goods?
Yeah, so I guess, okay, go ahead.
No, go ahead. It's cool.
Yeah, so I think if we're talking about scope 3, there will be double counting, and that's not a problem. Scope 3, we expect there to be double counting because the brand is going all the way up in their supply chain. So I don't think anyone's too concerned about that if what you're talking about is scope 3 reporting.
Okay, thank you. And we have one last question that's come up, and this is also an interesting one. When do you think that suppliers' Higg data, so energy, water, and chemicals, and I suspect this is more FEM data, will be applied into the MSI and product module?
Yeah, so that's a very complicated. It seems like it should be an easy thing. It's pretty complicated because right now they are so separate, and our LCA data isn't integrated with like FEM data. It's something that everyone's talking about. It's something that's a priority. So we're looking into this. I don't have a timeline to share, but just know that this is something that a lot of people are asking about, and it's a priority for us as well.
Yeah, this is really something that kind of everybody's looking for, that integrated view, but we actually don't have the level of computing or the capacity, the calculation capacity to actually manage this. To give you an idea, I think there are 15,000 facilities in FEM. So with these 15,000 facilities, each one of them has several data points around energy, water, chemical use, and greenhouse gas emissions, what type of energy, whether it's electric, whether it's thermal, what type of thermal energy. So quite a few data points for each one of those 15,000 facilities. And then in the MSI, we already have millions of potential combinations between raw material sources, processes, certifications. So if you multiply millions by 15,000 times 5, we actually don't have a way to manage that calculation well enough to be able to do it and to repeat it and in a system like this.
Yeah, I think the other thing about it too is that facility FEM facility data is reporting for the full facility, where MSI is process data. So right now, unless a facility is only doing one process, it's hard to figure out what's going into each separate process that they're doing. So this is all something that we're working towards. But yeah, again, no specific timeline. But with that, I think we answered most of the questions. So maybe I'll jump into the next section here, and then we'll still have a few more minutes at the end if anyone puts any other questions in.
Great, thank you.
So yeah, we have a few slides here that I think are hot topics in LCA and therefore also in MSI. I'm going to go through them pretty quickly, just giving a high level overview of what these things are. Again, we could probably spend an entire session on each one of these. I just have one slide for each. So I'm going to highlight them very quickly. And so you'll sort of understand the basic concepts. If you hear these terms, you'll be able to understand what people are talking about. So let's start here with the limitations. LCA and MSI do not measure everything, nor should it, and we do not expect it to. So MSI measures the 5 impact areas that we've talked about only, and it doesn't measure anything else. So this is a criticism that we get sometimes of MSI, saying like, oh, but you don't measure deforestation, you don't measure social labor issues, biodegradability, price, microfibers, etc. This does not mean that we don't think that these things are important. We do. We think all of these issues are really important. It's just that there aren't necessarily LCA methodologies that measure these things. So possibly when LCA methodologies evolve, we may add more categories as there are scientific methods to measuring these things. But for now, many of these impact areas are not advanced enough in the scientific community for us to implement. All something to keep an eye on. If different methodologies emerge, we will reevaluate. But I guess with the exception of price, I think everyone's already taking price into account when they evaluate materials, of course. So we encourage people to take these other things into account as well, like social labor issues and all these other things. So LCA and MSI offer a few pieces of what we think are very important pieces of information, but we don't claim that this measures everything related to sustainability. It's just not possible. Next, as promised, we have our biogenic carbon slide. Biogenic carbon is carbon contained in the biomass that's accumulated during plant growth. So as a result, many natural materials store or sequester atmospheric carbon dioxide in the short term. LCA standards tell us that in order to claim a reduction of global warming potential, so saying that you subtract it from your overall impacts, you need to prove that the carbon has been sequestered for more than 100 years in the product. At end of life, if the product is landfilled, there are methane emissions associated with degradation in a landfill. Burning releases carbon to the atmosphere. So it's pretty difficult to prove that something's actually sequestered for so long, especially in a cradle to gate LCA when we aren't even looking at the end of life stage. So in the MSI, biogenic carbon is not subtracted from global warming results, but like we've talked about a couple of times, it's displayed as a separate inventory metric. So users of the MSI can interpret that information how they wish. And again, that's consistent with LCA standards. In product module, again, that's something we talked about, but it's pretty complicated. So we just include it as a separate metric, again, consistent with LCA standards. So that's how we deal with biogenic carbon. Another topic that comes up a lot, we mostly see this around leather, but we actually use allocation in quite a few of our processes. Basically, allocation is answering the question, what if the process has other outputs? So we've talked a lot about measuring the inputs and outputs to a system, but here are 3 examples where we use allocation. So here's our example. We measure all the inputs and outputs for growing cotton or raising a cow, but how do we assign these impacts to different outputs if we're only interested in one of the outputs? So for leather, for instance, you're measuring the inputs, outputs of raising a cow, but it also has meat, it gives milk. There's a lot of different outputs to a cow. The first question to think about is if there is economic value to the other products. If there isn't any value to those other products, it's probably a waste and not a co-product, so we don't need to worry about it. But if there is value, like in all of these examples, we have to pick the right way to assign value. So the ISO standards give options, but really what you select depends on what makes sense in the context. These 3 examples, we use economic allocation, so the value of each of the outputs, but there are other options that are used, like allocating based on mass or on energy. So basically, this is just saying we give the environmental impacts a proportion of the overall impacts of the product based on the value of that product. So in the case of leather, the hide is a pretty small percentage of the value of the cow. I think it's about 3%. So the cow hides are just 3% of the impact of the cow. So this is our last topic here. So the last thing I just want to mention quickly, because we get a lot of questions about the European product environmental footprint work that's going on in Europe. Basically, it's a standard that's being evolved over quite a few years to report environmental impacts of certain product categories in a standard manner. So there is one for apparel and footwear. It's still under development. It's in draft now, being finalized in the next few years. Sustainable Apparel Coalition is closely involved in this and keeping a close eye on it, especially in relation to product module. But the product environmental footprint, or PEF for short, if you hear people talking about PEF, this is a work in progress. It's evolving. It's not final. So we're monitoring it really closely and are evaluating if we'll be able to align someday. But right now we're not, and but we're going to keep a close eye on it. So with that, we can take any more questions if any more came in.
We actually don't have any more questions that came in.
Okay, great. Yeah, so I guess we can give people another minute or so if there are any questions. If not, feel free to reach out. We're happy to answer any if you think of them after you're reviewing all this information.
Okay, well, thank you very much again. Thank you for attending. Thank you, Paula. And as I've said, we will send out the recording of this session with the email and also a PDF of the deck so that all of you can have access to it. Thanks again for your time and have a good rest of your day.
Yeah, thank you, everyone.